Welcome back. Today I'm going to talk about how you can use CorExtend to add instructions to your MIPS FPGA processor. So the goal of this module is to extend the functionality to add a user-defined instruction, or a UDI. The process is to modify the MIPS FPGA UDI module and then add the UDI instruction to your software. So I'll show this with an example, adding the NAND instruction. Here's a very high-level view of the CorExtend interface. It's going to interface with the MicroAptiv CPU. So for example, the original softcore includes only the OR, AND, NOR, and XOR logic instructions. We're going to extend that so that we can add another instruction, the NAND instruction. We're going to add the NAND instruction with CorExtend by using one of the UDI opcodes. So in this case, we use 011100, and then the typical MIPS instruction format, RS, RT, RD, and then the function code at the end. So for example, UDI1, $T4, $T3, $T5, 0 would be formatted as shown in the machine code. One thing to note is that these instructions list the operands in the assembly language as RS, RT, and RD in that order. So the next thing we're going to do is we're going to change the existing UDI, or user-defined instruction, stub module so that it can be used for the NAND instruction. We've provided this module for you at the location shown. 3 lines I'd like to point out are the actual performance of the NAND operation. Takes the first source operand, RS, second source operand, RT, NANDs those together, and puts the result in a UDI result signal. Line 166 then assigns that signal to the UDI result signal associated with the execute stage, shown by the post-pended E on UDI result _E. And finally, it takes that signal and sends it to the memory stage, UDI RDM, to be given as the result. The final step is to add our UDI instruction to our program. So here's an example of using UDI1. It's going to take T4 and T3, NAND those together, and put the result in T5. Note that the compiler supports mnemonics UDI 0 through UDI 15. In this example, it will display the result of that NAND operation on the 7-segment displays. So in this case, the answer should be hex, all Fs, and a D. So let's go ahead and try this out on the board. So first step is to plug in our Nexus 4 DDR board and the Bus Blaster probe. Turn it on and program the provided bit file onto the Nexus 4 DDR board. We'll browse to the provided bit file, program the board, and then press the CPU reset button to make sure the MIPS FPGA core starts running. And now we're going to download our program that performs the NAND operation. And as we can see, it in fact does perform the correct operation, producing the result all Fs and a D. You can use CorExtend to add any number of operations to your MIPS FPGA core.